This section is all about using this equation to figure out whether or not a reaction is spontaneous, or if you change one of these things, what that will do to the spontaneity. Now, the main thing that's going to determine whether or not a reaction is spontaneous is all about G. If G is negative, it's spontaneous. If G is positive, it's non-spontaneous. However, you can manipulate around the enthalpy and the entropy of a system and change the value of delta G, and thus change whether it's spontaneous or non-spontaneous. And so there's several different types of questions that will ask you to deal with. Some will have you do the math, which is actually kind of easy, and some of them will ask you questions like, if you increase the temperature, is the reaction more likely to become spontaneous or non-spontaneous, and why? And those are a little bit harder, so we're going to look at both of these. So let's take a look at this example down here. This has two parts. The first part asks us to predict the direction in which the free energy for this reaction changes with increasing temperature. Now, if the temperature is increasing, then what that does to delta G is all about delta S, if delta S is positive or negative. So we have to look at the equation here and decide if delta S is positive or negative. Here we have 4 moles of gases turning into 2 moles of gases. So this reaction is becoming more ordered, it's becoming less disordered, and so delta S is going to be negative. So a negative delta S multiplied by this negative T here is going to result in a positive value for T times delta S. And so that means that we're adding delta H to this value that we get here. And so our delta G is going to start to increase. So it's either going to become less negative or more positive, depending on what delta G is to begin with. Now, to do the next part of this problem, we really can't do this unless we have a value for delta H and delta S, so we have to go back and look those up. If I go look up delta H and delta S, I get these values here. Watch your units carefully, always with this equation. Delta S is usually in joules, while the other two are in kilojoules, so I'm going to need to change that. And I can just plug these numbers into my equation. And here's what we get for the 25 degrees. And here's what we get for the 500 degrees. So we can see that the prediction that we made earlier, that delta G will become less negative or more positive as we increase the temperature, is true. And let's take a look at this example problem here. Alright, here we have liquid water that is vaporizing, and we are trying to figure out what happens to the enthalpy, the entropy, the free energy, and the temperature change. And we gotta explain why we think what's happening is happening. So I'm going to start just with an equation, just because it makes it easier for me to visualize what's happening. You don't have to do this though. And I'm going to start with the easiest one for me to figure out, which is entropy. Entropy is the easiest one for me to figure out because it's going from a liquid to a gas, which means it's becoming more disordered, and so it's going to be a positive delta S. The next one that's probably the easiest to figure out for me is enthalpy. Here I have water turning from a liquid to a gas. It requires energy, it absorbs energy whenever it goes through this state change. Therefore it is endothermic, so delta H must be positive. To figure out the free energy sign, I look at whether this reaction was spontaneous or not. I didn't really have to do anything to it, so it's a spontaneous reaction. That means delta G should be negative. And to figure out the temperature change, anytime you have water evaporating, it removes energy from the system. It's a cooling process, so the temperature should decrease a little bit. And let's take a look at the second problem. We have ammonium chloride added to water. It dissolves. The temperature of the system decreases. We want to know enthalpy, entropy, and free energy changes during the process. So again, I'm going to go ahead and start with an equation just because it's easier for me to visualize what's going on. But again, you don't really have to do that. Alright, so on this one, I'm going to start with temperature decreasing. If the temperature decreases, it means it's an endothermic reaction. So we're going to have a positive delta H. Since we have a solid dissociating into ions, it is becoming more disordered. So its entropy is increasing, so positive delta S. And to predict free energy, we'll look and see if the reaction was spontaneous or not. Put it in water, it dissolves, and it dissolves pretty easily without any kind of outside help. So this is a spontaneous reaction, so negative delta G.